This is question 8 in exercise 21.6 in Project Maths 2. A ball is fired upward vertically from the top of a building which is 30 meters in height. The approximate height h reached by the ball after t seconds is given by h equals 30 plus 25t minus 5t squared. So we have to graph the f of t in terms of h in the domain 0 is less than or equal to t is less than or equal to 6, and we've got to use our graph to find the following. Might be easiest to try and break down what's going on here so we can see what this all means. So the ball is fired upward vertically from the top of the building, so we are already starting 30 meters in the air and a ball is being projected straight upwards. Alright, the formula that we are being given to calculate its height in relation to the amount of time it has spent in the air is given by our function here, h equals 30 plus 25t minus 5t squared. In other words, if we put in a number for the amount of seconds it's been in the air to this equation, we will get back from it the height in the air that the ball is at. So for example, if we put 0 in, and that means it's going to be right where we started, and it'll just be 30 meters above ground. And we have to graph that all in the domain of 0 to 6. Now how we graph a function is demonstrated in another video, but we can see here on the left what the graph will look like. So it starts off 30 meters above the ground, and then our progression from left to right is time, not distance from the building. So our time goes along the bottom here, our height goes along the top, and it goes up into the air for a certain amount of time and then comes back down and will hit the ground eventually. But we'll go through the questions one by one here. So for part 1, we've got the maximum height reached by the ball is what we have to try and find out. So if we go to our graph, right at the very top of the curve, just up here, is where the ball is going to stop going up and then start going back down again. So what we're going to do is we're going to just cover that line right the way across to the y-axis. Now when you're doing this in your actual work, you'll use a ruler to do this. And you can see that that is somewhere between 60 and 65. Somewhere in the region of maybe 61 meters if I've drawn it correctly. So for part 1, we can say that the maximum height it reaches is about 61 meters, approximately. For part 2, we've got to find the number of seconds taken for the ball to reach a height of 60 meters for the first time. Well, 60 meters is just here, and if we follow that over to the graph, this point here is where the ball will first hit 60 meters high. And if we then just follow the line down from there, we can see that that happens after 2 seconds. So it takes 2 seconds for the ball to reach 60 meters. For part 3, we're asked for the number of seconds taken for the ball to be at a height of 60 meters again. So 60 meters again is going to be over here. And this part of the graph is where the ball is now descending. It's now dropping back down after reaching its max height. And if we follow that line down to our x-axis, which is representing time in this case, we'll see that that's going to happen after 3 seconds. Or depending on how we interpret that question, we could say 1 second later. In other words, it happened 1 second after it first reached 60 meters. For part 4, we're asked how high the ball is after 4.5 seconds. So 4.5 seconds means we're going to go to our x-axis because that's where we've got our time represented. And we got a 4.5, which is just here. And then we follow that line up to the graph. And it get to a point just here. And then we're going to follow that line over to the y-axis. And we're going to get a height of about 41 meters, approximately. So we get about 41 meters out of that. And we look at part 5. We've got after how many seconds the ball will reach the height from where it started. And the ball started at 30 meters, just over here. And the next time it reaches 30 meters is just over here on the right. So if we follow that line down, we can see that the ball will reach 30 meters again, like as in for the second time, after 5 seconds. So it's 5 seconds of flight. And then for part 6, we're asked after how many seconds will the ball reach the base of the building. Now we're to assume that the base of the building is 0 meters in height. And if we look at our graph, our ball reaches 0 meters in height right down here at the very end after what looks like 6 seconds. And that is that.